properties of real numbers is something that is not new to you, and it's going to seem very repetitive, but we go over this again and again each year because it is more and more important. It tells you what is a legal move in math and what is not. It's helpful to simplify algebraic expressions that you couldn't have done otherwise without these properties, and also to make mental math easier. So the target is that you can identify and you can use these properties of real numbers. First, the commutative property. You have this of addition and of multiplication. So with addition, it says you can add numbers in any order. So A plus B is equal to B plus A. I can switch the order of everything. 14 plus 5 is the same thing as 5 plus 14. This also applies to multiplication. It says you could multiply numbers in any order. So A times B is the same thing as B times A with numbers. Negative 9 times 3 is negative 27, and so is 3 times negative 9. That is also negative 27. The associative property of addition, that says you can change the grouping of numbers and it's not going to change the sum. So I could have A plus B in parentheses plus C is equal to A plus B plus C in parentheses. And if you think about this, the parentheses, all they do is they change up the order, which goes back to the commutative property. Order of operations tells us to work what's in the parenthesis first. So 21 plus 4 in parentheses plus 7 is equal to 21 plus 4 plus 7 in parentheses. Here's how we know this works. 21 plus 4 is 25. And then over here on the other side, you would have 21 plus 4 plus 7 is 11. Either way, you're going to add up to get 32. So 32 equals 32. With the associative property of multiplication, it works the same way. You can change the grouping of the factors, which are the pieces that are being multiplied, and it will not change the product. A times B in parentheses times C is equal to A times the product of B and C. So I can multiply 8 times 3, then times 6, or I can do 3 times negative 6 and then multiply that times 8. The identity properties, these basically tell you that you're going to get the same thing that you started with, that the operation does not change the number. The sum of a number and its additive identity, 0, is the number. Don't confuse this with the additive inverse. We'll look at that next. So A plus 0 is A, because it's just like 45 plus 0 equals 45. Some of the easiest adding you originally did in elementary school. The identity property of multiplication is similar, but you're using a different number. The product of a number and its multiplicative identity, 1, is that number. So anytime you're multiplying times 1, you get whatever it is you started with. That's why when you do times tables practice, they don't usually check your ones because it's very easy. It's just whatever the other number is. A times 1 is A. This is also why you will rarely ever see in algebra 1A or 1x. They'll drop that coefficient and just call it a or x because 1 times a is a. So negative 3 times 1 is going to be equal to negative 3. Now here's the inverse property that I was kind of alluding to. The sum of a number and its additive inverse or its opposite is 0. If I have a plus negative a, it's going to be 0. Because like if I had 6 plus negative 6, that is going to equal 0. Think of it this way. I have $6 in my pocket. That's like 6, that's positive 6. If I combine with that $6 of debt, meaning I owe my mom $6, well, really when I combine the $6 in my pocket with my $6 in debt, I end up with $0. What we've been using is something called deductive reasoning. It's reasoning logically from given facts to a conclusion, like when I was proving each of those properties. So 5 times 3n, that's like I have 3n plus 3n plus 3n plus 3n. I'm just so fast, it can't keep up with me. Plus 3n. Whoa, it's way up there. I wonder if that'll move down. Maybe? I tell you what, just too fast for it. Okay. If I were to combine all those, I would have 3, 6, 9, 12, 15 n. That is equal to, if I would have multiplied first 5 times 3 and got 15, and then that n is just on the side of it. What property is this showing? It's showing the associative property of multiplication. I have changed what is grouped together. So deductive reasoning is what I do. I reason logically to form a conclusion, to prove the associative property of multiplication. And you can do that with each of those properties. An example showing that a statement is false is called a counterexample. Like 5 times 3 is not equal to 3 plus 5. I could use that as a counterexample. It's used a lot of times to prove that subtraction is not commutative. 5 minus 3 is not equal to 3 minus 5. That's because 5 minus 3 is 2, whereas 3 minus 5 is equal to negative 2. So that is a counterexample that shows that subtraction is not commutative. First, let's look at these equivalent equations and see what property is being used. On the first one, 27 times pi is equal to pi times 27. You'll notice that the order has been swapped, which tells us it's the commutative property, because that says that the order doesn't matter. Either way I multiply this, I'm going to end up with 27 pi. So we will name this the commutative property. And there are two commutative properties. There's one of addition and one of multiplication. And clearly this is multiplication. On the second practice problem, 5 times the quantity 12 times x is equal to the quantity 5 times 12 times x. This is something that you would actually use, because when you go to multiply 12 times x, you can't really do anything with that. However, if I go and move the parentheses to the other end of the expression and I multiply 5 times 12 first, I could get 60 and then multiply that times x, which is what's happening in your brain if you were to actually multiply all that together. What has changed is the grouping has changed. The order is the same, 5, 12x, 5, 12x. What has changed is in the first one, 12 and x are in the parentheses, and on the second side, 5 and 12 are together. So this is the associative property. And like with commutative property, there is a property of addition and a property of multiplication, and this is, again, of multiplication. The question when studying properties is always, how do I actually use these properties? Because it seems kind of pointless just to be able to name the properties. The application comes in using these properties. So take something like this, 55.3 plus 0.2 plus 23.8 plus 0.7. If we're trying to do this in our head, it's not really going to work very easily. I know that would be 55.5, but then I come to this and I have to carry decimals, and that's difficult to do in our head. So then I have to get out pencil and paper or get out my calculator. However, what I can do is I can look for compatible numbers. 55.3 goes very well with 0.7 because the 0.3 and the 0.7 becomes one whole. So 55 plus 0 is 55, and then the one whole that was made from 0.3 and 0.7 makes that 56. Then we're going to look to 0.2. It is compatible with 23.8 for the same reason, because that creates the whole number 1. So that goes from 23.8 to 24. So then I have 56 plus 24, and I can add that in my head. 6 and 4 make 10, carry 1. 1 and 5 make 6. 6 and 2 makes 8. So what properties did we use here? Both times we use the commutative property of addition. Because I switched the order in my head. I did the ones that we underlined in blue first, and then I added what was underlined in red, and that made it much easier to do in our head, and that is a legal move in math because of the commutative property.